When a mass of ice the size of Florida shatters into the ocean, the impact is felt globally. This remote wall of ice at the bottom of the world earned the nickname the Doomsday Glacier, but recent expeditions show that its retreat follows a much stranger logic than a sudden collapse. This is the Thwaites Glacier, a sprawling sheet of frozen fresh water locked onto the coast of West Antarctica. It serves as a massive physical keystone, holding back an entire continent of ice behind it. That keystone is deteriorating. Every single year, Thwaites sheds more than 50 billion tons of ice into the surrounding sea. This animated map shows Thwaites acting as a physical plug. If that cork gives way, the rest of the West Antarctic Ice Sheet could freely flow into the ocean, raising global sea levels by 10 feet. Because this single geographic feature dictates the future coastlines of the entire planet, its stability has become the primary focus of modern glaciology. Researchers launched a $50 million international effort to secure answers on the timeline of this retreat. The goal was to quantify exactly how much water Thwaites will add to the ocean and how quickly it will happen. Accessing these answers required scientists to reach the grounding line, the hidden underwater boundary where the ice detaches from the solid bedrock and starts floating on the sea. Collecting this data required coordination between experts at the NSIDC and CIRES. The NSIDC is the National Snow and Ice Data Center, and CIRES is the Cooperative Institute for Research in Environmental Sciences. Together, they unified the findings from 8 separate field projects operating in the extreme cold. The data collected on the ice revealed 2 specific and contradictory forces. These discoveries show that while Thwaites is hollowing out from beneath, its structural collapse follows a timeline that differs from our previous expectations. Curious, energetic, one discovery came after researchers drilled a narrow hole 2,300 feet deep and submerged a torpedo-shaped robot named Icefin to inspect the grounding line up close. Paired with satellite radar data from a team at UC Irvine, the researchers identified a violent daily cycle. The entire ice sheet is physically heaving up and down, driven by the natural rhythm of the ocean's tides. This cross-section diagram illustrates a process called tidal pumping. As the high tide pushes up on the floating edge of the glacier, it lifts the ice just enough for warm, salty seawater to rush underneath, traveling as far as 12 kilometers inland. That high-pressure saltwater becomes trapped in cavities beneath the ice sheet. It generates enough force to jack up a half-mile thick column of ice, melting the glacier's foundation from the bottom up. This hidden daily assault injects the thermal equivalent of 10 million kitchen ovens directly into the glacier's base, hollowing out Thwaites faster than earlier estimates predicted. While the bottom of the glacier is vanishing rapidly, researchers at Dartmouth College found a surprising counterweight to that data. They used high-resolution computer simulations to test the likelihood of a sudden runaway collapse. They were investigating a specific threat called marine ice cliff instability, or MICI. MICI is a scenario where towering, exposed ice walls become so tall and brittle they crumble under their own immense weight, triggering a chain reaction of collapsing ice. The Dartmouth model showed that the physical geometry of Thwaites provides more structural stability than previously thought, making this specific type of rapid cliff failure unlikely for the remainder of this century. Although the glacier is continuously losing ice to the sea, it is not currently following a path toward total structural failure before the year 2100. This is the Doomsday Paradox. The glacier is being aggressively hollowed out by the tides, yet its final collapse has been delayed. Synthesized, the data reveals that Thwaites behaves like an hourglass that has been flipped over. The sand is steadily running out, even if the glass itself remains intact for now. The saltwater pumping underneath the ice guarantees a grinding, continuous melt. That process alone will add enough fresh water to the ocean to drive sea levels higher, even without a dramatic cliff collapse. Coastal communities still face a creeping, inevitable threat. Rising water will slowly swallow infrastructure, submerge highways, and force mass relocations. This delay in total collapse serves as a call to action to adapt our coastlines and reduce emissions before the tidal melting becomes irreversible. The Doomsday Glacier has offered us a lifeline. Whether we use this borrowed time to prepare or ignore the warning is now entirely up to us.